Alright, so in this video, we are going to have a look at the type of reactions. Okay, so there are four type of reaction that you are going to learn. So the first one, we are going to look at the elimination reaction. So how do you identify if the reaction that you have is an elimination reaction? Actually, that's easy to do. Okay, just have a look at your reactants and product. Okay, if you got a single bond in your reactant, but then in your product it become a double bond. Okay, so that means the reaction is an elimination reaction. So basically, the elimination reaction is one of the methods to prepare a multiple bond compound. The second reaction, we have a rearrangement reaction. Okay, so in this reaction, okay, it's involves the reorganization of the bond and also or the atoms. Alright, so basically for the rearrangement reaction, okay, the bonding and also the atoms does not change, but maybe the position of the atoms or the bonding will be changed. Right, so basically if your reactant got 2 carbon, your product also got 2 carbon. If your reactant got 3 hydrogen, your product also got 3 hydrogen. If your reactant got a multiple bond, a one carbon-carbon double bond, for example, your reactant, your product will also got one carbon-carbon double bond. Right? So the bonding does not change, the number of atoms does not change, just maybe the position of the atoms or the bonding will be changed. The third type of reaction, we have an addition reaction. So generally, to identify the addition reaction, okay, have a look at the reactants. Okay, your reactants generally will have a multiple bond. For let's say if you have a double bond, it will become a single bond. If you have a triple bond, it will become a double bond. Okay, so that means, okay, if you have this kind of reaction, that means the reaction is an addition reaction. Why does this happen? Because we are going to add something in our reactant that makes the one of the bonding disappear, and then the double bond will become a single bond, a triple bond will become a double bond. But there are two types of addition reactions. So we have an electrophilic addition and also a nucleophilic addition. So basically for the electrophilic addition reaction, right, so we have it involves a carbon-carbon double bond. Okay, we will convert it into carbon-carbon single bond, or a carbon-carbon triple bond, it will become a carbon-carbon double bond. So if you have a reactant that involves these two class of compound, okay, and then it change into carbon-carbon single bond or carbon-carbon double bond, that means the reaction is an electrophilic addition reaction. This happens because, okay, on the double bond here, okay, we have a high electron density, so it will act as a nucleophile. Alright, so this double bond, this nucleophile will attack an electrophile. So the one that we will add into this first is an electrophile. So that's why we named it as an electrophilic addition, because the one that will enter this compound is an electrophile first. For the nucleophilic addition, basically it involves in carbonic compounds where the carbon double bond O will become carbon single bond O. This happens because, okay, between carbon and oxygen there is a difference in electronegativity where carbon is partially positive and oxygen is partially negative. Okay, so the reaction actually will happen to the carbon, which is our electrophilic site. So the one that will attack this carbon is a nucleophile. So the nucleophile will attack this electrophilic site, so that's why we call it as a nucleophilic addition reaction. And last but not least, we have a substitution reaction. For the substitution reaction, okay, to identify the substitution reaction, okay, the bonding does not change, but the reactants will exchange parts so that you can see in your reactant and your product, okay, there's some difference. So there are three types of substitution reaction. For the first one, we have a free radical substitution where it involves in alkane or cycloalkane, okay, that will be reacted with chlorine or bromine under UV or sunlight. Okay, so this one will undergo free radical substitution. The second one is electrophilic aromatic substitution. For the electrophilic aromatic substitution, it will occurs on the benzene ring. So the reaction will occurs on benzene ring. On benzene ring, each carbon actually got one hydrogen atom. So we will substitute one of the hydrogen atoms on the benzene ring with other atoms or compound. Okay, for example, here we have one hydrogen, and then for the product we substitute it to chlorine. Okay, so make sure the reaction occurs on the benzene ring. For the nucleophilic substitution reaction, okay, we are going to substitute our nucleophile with another nucleophile. For example, if you have an alcohol, the hydroxy group is our nucleophile. Okay, so we are going to substitute this nucleophile with another nucleophile, which is here is Cl minus. So Cl minus is our new nucleophile, so we substitute the nucleophile with another nucleophile. Now, let's have a look at our tutorial question, okay, for reaction A, right? So, if you look at this reaction, okay, the bonding does not change, okay, so we have aromatic ring here, we have aromatic ring here, the C double bond O, C double bond O, C single bond, C single bond, so the bonding does not change. So we know that this reaction is a substitution reaction, right? So we have a substitution reaction. But the substitution reaction got three types, okay? So which one of this? Okay, so since the reaction, our reactant here, okay, we have OH, okay, on the reactant, but then our product, the OH, is changed into the Cl. Okay, so OH is our nucleophile, and then we substitute it with another nucleophile. So actually, for this reaction, it is a nucleophilic substitution reaction. B, for B, right, our reactant here, we got a carbon-carbon double bond, but our product now, the carbon-carbon double bond is not there. Okay, so basically carbon-carbon double bond become carbon-carbon single bond. So this one actually is an electrophilic addition reaction. Again, for C, carbon-carbon double bond, but here there is no carbon-carbon double bond, so carbon-carbon double bond becomes carbon-carbon single bond. Same like B, it is an electrophilic addition reaction. D, our reactant is carbon-carbon single bond, but our product, it becomes a carbon-carbon double bond. So for this one is an elimination reaction. For E, alright, so we have alkane, a methane, react with Br2 in the presence of UV. So if you still remember the reaction that involve alkane, okay, it is a free radical substitution. Each carbon in the benzene ring got one hydrogen atom. Alright, so this hydrogen we substitute into NO2. Alright, so the reaction is the substitution reaction, and because it occurs on the benzene ring, okay, it is an electrophilic aromatic substitution reaction. So G, we have a cycloalkane reacted with Br2 in the presence of UV. So again, it is a free radical substitution reaction. H, the carbon-carbon single bond become carbon-carbon double bond. So it is an elimination reaction. For I, okay, so the reaction occurs on the benzene ring because the hydrogen here, we change it into this, right? So this one is electrophilic aromatic substitution reaction. And then last but not least, okay, we have this reaction, okay. So here we can see that the bonding does not change and the number of atoms also does not change because we have 3 carbon on the left and then 3 carbon on the right, okay. 6 hydrogen on the left and also 6 hydrogen on the right, 1 oxygen, 1 oxygen, 1 one double bond and one double bond. Only the position of double bond is changed. So this reaction actually is a rearrangement reaction.